Give me 1 second here and then we'll start. All right, I think we are live now. Yep, we're live. All right. Hello everybody. Welcome to the stream. The Food Kid, Jack Plays, and Arctic Studios official. Finally caught a stream. Is everyone even there? All right. Hello and welcome. So I'm going to talk quickly about the event going on right now, and then I'm going to talk about the event for tomorrow. So quickly for the event going on right now, we have a slight risk in portions of Louisiana, Mississippi, and Alabama, and a little part of the Florida Panhandle. This is driven by a 5% tornado and a 5% wind risk, or 15% wind risk, and then also a hail risk back there. That's where storms are happening right now, is where that hail risk is right there. Hello, Storm Spotter. Hello, welcome, welcome, welcome. All right. And then right over here, we do have a tornado watch right now. Tornadoes is moderate concern. Main threat this is severe wind and hail currently. So let's check out the radar real quick, and then I will talk about the event that's happening tomorrow, where I will be storm chasing. You have no clue what this means. All right. That's okay. All right, give this a second real quick. All right, so down here we do have a tornado warning right now. So that just got issued. We check out this person's stream right now. He's in the middle of the field and there's no visibility. That's kind of the problem right now. All right, where is the closest radar to this? Right over there. So if we check out what's going on right now, we do have a cluster of supercells, it looks like. And yeah, there's definitely some rotation on that. So there's definitely rotation on it. Probably not on the ground. Check if it is on the ground though. Yeah, definitely not on the ground, it looks like. But yeah, this just looks like a big mess out here. I certainly would not want to be there. Yeah, not much to see right now. We just got this big line right over here. And this will be continuing this way. And then kind of just move up that way. So yeah, there's not much right now. So let's talk about the event that is going to happen tomorrow. So if we go over here, this is tomorrow's convective outlook. So as you can see, from anywhere from Wilmington all the way down to Tallahassee, you're in a slight risk. There's a 5% tornado risk from Tallahassee to Wilmington. And the wind risk is what is driving this event with a 15% risk from the Gulf all the way up to Wilmington. And then there's also a 5% hail risk with any supercells that do develop. And that one looks like it's from Jacksonville all the way up to around Fayetteville. All right. So this is Colorado State's new like severe weather forecast. It's kind of made by it's AI that takes the models and makes a forecast of its own. Arctic Studios, thank you for the $10. Wow, thank you so much. That's actually amazing. Thank you, Arctic. You keep on donating. Been wanting to donate for a while, but can't catch a stream. I don't know, just wanted to say hi, and I sit 3 million visits on snow plowing game. Yeah, if you do play Roblox, play Snow Plowing Simulator. That's a really cool game, and Arctic made it. I like playing that game a lot. This is confusing for you. I'm sorry that it is. I'm trying to make it as simple as I can. You can become a member. That would be nice if you could, but you don't have to. Will this possibly hit Florida? Yeah, Florida Panhandle will be in the most risk, but you can see like damaging winds all the way down to Miami. So yeah. Let's see. Yeah, pretty good rotation on that cell that I was showing you guys earlier. So if we do check out this right here, this is just like simulated forecast. So this is the tornado risk for tomorrow. So as you can see, let me just, oh, wrong. Let me zoom in on this. All right, so as you can see that green is a 2% chance of a tornado within 25 miles of your house. The like brown is a 5% chance of a tornado within 25 miles of your house, and the yellow is a 10% chance. So a 10% chance is quite a bit. Let me fix the screen over here 1 second. All right, Carolina Chasers, join Lounge VC on your Discord. Once I'm done with this, then yes, I will. Snow truck plowing simulator event in the snow truck plowing. Let's see. Got it. All right, and then also here's your hail probability down here in Georgia. That's also where your 10% risk is. There's a 15% chance of seeing 1 inch diameter hail or larger down there, and then a 5% chance all the way from Virginia down to Florida. And then here's your damaging wind. So right there where that black dot is, that's where you have a 30% chance of seeing a 60-mile-per-hour wind gust 25 miles from your house. And then the yellow is 15, and that brown is 5. All right, so enough looking at that. Let's look at some forecast models. So let's first start off with what the winds look like in the upper atmosphere. This is around 15,000 feet aloft, so this is the 500 millibar level. So right over here, you can see a big trough that is driving the system currently down here in the south. So as you can see, this is positively tilted, which is normally not that good for severe weather, but they're making it work down there since then it's kind of harder to get that like warm air flow into there. But if this was tilted the other way, where it was like that, here actually I have a drawing tool. Let me use that. All right, so if it was instead tilted like that, then all of this, let me make it bigger. Then all of this from the Gulf would stream right up here, and then right there you would have a big severe weather right there. So that will eventually happen, but right now it is not. So if we do play this through, as you can see, that trough continues to advance. And then right up here, you do have a trough on the polar jet stream. So this right here, if I clear this, this is the subtropical jet stream. This is the polar jet stream that's all finicky and everything. But then right over here, oops. Oh, okay. Maybe not. Okay, right over here, you do have a trough coming down here, and this will interact with this trough and kind of make this area right over here more powerful in the trough. Let me just play it through, and you can see. So as you can see, right here, right here, right here. All right, so right here, this trough, it looks like it's like really like stretched out and not that severe, but really like draw it like that, and then there you go. You have yourself a crazy negatively tilted trough right there, if you see. And then right over there in the Appalachian Mountains right there, you got 100 knot winds right over there, 15,000 feet above you. So right over here, this should make for severe weather that is happening tomorrow, right down here. All right, anything in the comments? There's not a significant tornado risk in there. That black dot there. All right, the website for this model here, if you wanna, you just search up on Google CSU MLP, and then it's that first thing right there, and then you press severe WX forecast. You can do day 1, day 2, day 3, the medium range, and stuff like that. Just mess around with it, and you'll get the hang of it. All right, and then if we play this through, so this right here is 7 a.m. on, or no, 7 a.m., sorry. This is 7 p.m. tomorrow, so right over there. This is whenever the trough is kind of the most intense. And then if we do start out the day right here, this is 12Z, so 7 a.m. tomorrow. As you can see, our main severe threat's right over here, like kind of up here more. And then if we play this through, there. And then that other trough from the polar jet stream kind of digs down, but it won't have any moisture for it, so it will not do anything. And then as we pull this through, right over there, you can see our next big potent system. This is right over here on March 18th. So this is another big system watch out for, but that's not for a long, long time. All right, one other thing. I want to look at the low level jet stream. So right over here, 850 millibars, just around like, I think around 5,000 feet above our heads. So this is the low level jet stream. So if we do play this through, this one, there's no like really distinct characteristic. There's kind of like something there. But really, you want this to be like kind of straight out of the southeast if you do want supercells. So as you can see, this is kind of out of the southwest. So that's still, it still can get supercells from that, but it's not as good as from the southeast. And then right over here, you have a really nice low level jet right here, but this is right before the storms initiate, so it is kind of timed bad. So give me a second real quick. But we do have a lot of flow from the south, so that is good. That is good. This is around right here's the time that storms should be the most severe in this area right over here. Maybe a little bit earlier, like right here for Georgia areas. All right, and then if we move right over here, this is the wrap model, and this is our mid-level cape. So cape, if you take a parcel of air in the mid-levels, and basically how much energy there is, decides on like how fast and far up that can be forced up. So if we do play this back right over here, your pink colors are marginal energy. Your blue colors are decent energy. Your green colors are pretty great energy. Yellow is amazing. Red is even crazy. And yeah. So if you do look at this right over here, and this is 10 a.m. in the morning tomorrow. Or no, sorry. This is 7 a.m. in the morning tomorrow. And then this is 10 a.m. in the morning. This is 1 p.m. And then you can see you get that flow from the southwest, which is causing all of this moisture to rise up and all the energy. So right over here, this is 23Z. So 6 p.m. right over here. As you can see, we have some areas that we are going to take a sounding for. So right there, you got 1,120 joules per kilogram of mid-level cape right there. So that's good. We'll also take one kind of near the coast. Right about there, I think. And then one more, kind of more up, right there. All right, let's look at these. So this is our one in the most severe area. So as you can see, zoom in on this and get this. Here, how do I hide this? There we go. All right, so right here, as you can see, we have quite good cape, which is kind of surprising since we aren't going to get clouds, but we'll get it done somehow. How can I clear this without having like, I don't know if there is any way, but that's fine. All right. So yeah, pretty good. 1,163 joules per kilogram of mid-level cape. So that is quite good. We also have the SIN shouldn't be an issue, so we do not have that much dry air in place. And then as you see right here, this is our moist layer. It's not that deep, but like you kind of don't want moist, like very moist temperatures right there at the surface, as that could cause like messy storm mode. So here is your mid-level parcel. As you can see, it goes all the way up there into 12,000 kilometers. So yeah, it goes very, very high up. And then as you can see, the wind change of height is around there to around there. So it's not that much shear actually. Which is the one thing that could make supercells not be able to form. Also lapse rates are decent. Like for really good lapse rates, you would want that red, which is your temperature. You would want the change in height to be like that. That would be amazing lapse rates, which would like it would just fuel the storm in general, honestly. And then our shear right there, storm relative helicity around 100. That's not that good, but that could support some supercells. And then right over here, our hodograph, there's not that much low level shear, but it does get vented out nice. Alright, Bat Zero, Sahani, I don't know how to say it, I'm sorry. Hello, and this and that with Mr. Newsboy. When are we done with the weather briefing? Probably about 20 minutes. Yeah, we could continue streaming the live severe weather. What are you using to draw? I don't know. I just went on the Chrome Web Store and searched up draw tool. Yeah, definitely not very much spin. All right. So that's one of our soundings. Let's look at the next one. This one. Oh wow. Okay. This one was near the coast. This one has a lot more shear. Gotcha, gotcha. I think this one was near the coast. Do you remember where this one was? I don't remember. Let me play it back real quick. See where I took that second sounding from. Yeah, this one was near the coast. So this one, the cape levels are not as good, but the shear is quite good for sure. Let me just hide this real quick. That low level shear right there, that's pretty good. That's what you want to see. And then good venting out right over there. If we look over here, the storm relative helicity is quite nice at 200. That will definitely support supercells. Cape 839 mid-level cape, right there. That's decent, but it's not the best. Another thing that's kind of holding back this event is the low cloud level. It's really low, which could make it very messy. But not as low as it is in Louisiana today. Louisiana is just a mess today. And then right over here, oops. Oh, I'm clicking on all the wrong stuff. All right, right over here, this is a lot more deep of a moist layer, which is good. You do want a more deep moist layer. And then there, you do have a yeah, right there. You have some dry air right there, which is kind of, you want sin, but not too much, because like, if you have too much sin, then storms can't form. And if you don't have any sin, then like the second that there's moisture and there's instability, it'll go. Like you want that instability to be able to build up before the storms initiate. And then right over here, you have your winds coming out that way, or coming out the south, and then once you get up to the top layer, you got it like that, which is a lot more favorable. And then that hodograph as well looks really nice. Significant tornado parameter is around like a weak-ish tornado. Maybe you could get one significant tornado. I don't think this will be a big significant tornado threat. And then this one was more north in North Carolina. Not north in North Carolina, but like in North Carolina. And this one actually is quite nice. I do like this one. The low level shear is not as good as the one taken at the coast, but it's still better than the one taken in central South Carolina, and then good venting as well. Right there and right there. You got pretty decent shear. Storm relative helicity at about 170. You can't get a supercell with that, but it's not that favorable. You got small low dry area right there, and then relatively deep moist layer. It's decent. And then a big dry area right over there, which I mean that's kind of good. Ooh, mid-level lapse rates are nice. 7. Nice, that's nice. 3 cape. I mean, I don't look at 3 cape that much, but 101, that's good. That's good. That's good. So there definitely could be something here. It won't be like a big outbreak or anything, but there definitely will be something. All right. What else did I want to look at? We'll look at a couple more parameters on here. Um, I do like looking at the supercell composite, so we are gonna look at that real quick. All right, let's pull this through. And yeah, so it looks like down here you do have quite a lot of supercell composite. This is just a whole bunch of like parameters all put together. So if we take one down here in South Carolina, I don't think I'll be able to make make it there in time. That's 4 p.m. Yeah, I cannot make it to South Carolina in time. But wow, you got 1,245 mid-level cape, some great storm relative helicity, decent hodograph. Yeah, it does look nice down here. Excuse me. Yeah, definitely looks more nice down there than the north does. But if you do take one up here in the north, let's look right over here. Got about 5 right there. There we go. All right, let's take this sounding, if it will load. Are there going to be tornadoes in America tomorrow? Yeah, there will be at least one tornado in America tomorrow. Is Waco, Texas going to get tornadoes tomorrow? No. You guys had your severe risk yesterday. You're not going to get any tomorrow. You remember from Roblox? Yeah. Which area tomorrow? Here's the Storm Prediction Center's graphic. All the way from the Gulf Coast Panhandle, all the way up to Virginia Beach, basically. And as wide as Atlanta to Charleston. All right, let's look at this right here. This was taken in North Carolina. 1,000 mid-level cape, quite good. Deep, moist layer. Relatively deep. Great shear. Great hodograph, actually. I do like that hodograph a lot. Yeah, this one looks pretty decent. So there definitely will be at least one supercell, I say. So this is the HRRR's. We are going to look at actually some of the convective real quick, just to compare it to that of the wrap. And if we do pull this forward, we need to go to 18Z. We do pull this forward. It's a lot more cape than the wrap had. All right, if we look at that right there, 1790. We cannot take soundings on this. We'll do that in pivotal weather. So I guess we will look at the precipitation real quick. So we'll look at the simulated reflectivity. This is what is supposed to happen. So pulling it forward right over here, South Carolina and North Carolina starting to get the rain, like literally at like 12 o'clock tonight. And then that heaviest rain kind of coming in at around the early morning hours, like 5 a.m. And then right there, then 18Z, you start to get a little bit of instability, although those are very scattered. Once this whole thing moves out, then it looks like the cold front's about back here. So these cells should be able to develop in around central or western, be really weak. Then they'll advance into eastern North Carolina, and one or two could become supercellular. If you're looking down right here, you got a supercellular one right over there, one right there, and possibly one right there. And then it's over. So HRRR has been showing basically nothing the entire day. This is the first run of HRRR. It's actually showing something. And then right over here, you could have a tornado in this line that's coming through at around 1 p.m. in South Carolina. And then Georgia, after that line comes through, it looks like you won't really have anything. So your main severe threat, Georgia, will be with that line. And there definitely could be some embedded tornadoes in that line for sure. All right. Let's move over to pivotal weather. And if we do have a look at some of these models, first I'm going to do the HRRR real quick and get some soundings. Should do the significant tornado parameter. No, Supercell Composite. I like Supercell Composite better. AJ Boom, hello, welcome. Yeah, that is a nasty cluster. Update on that warning? Sure. So right over here we do have a tornado warning right now. We got some chasers there. Brad Arnold. Looks like there's not much. Brandon Kopic. A bunch of rain. Vince Walty. Whole bunch of rain. Yeah, that's really the main story down here. A whole bunch of rain and maybe a tornado or two. Lots of severe wind gusts. Alright, anyways, Supercell Composite right over here. Alright, let's take a sounding right there where it's an 8. What? Alright, right there. Alright, let's see here. Wow, alright, 1,151 joules per kilogram. Mid-level cape, great storm relative helicity right there. Pretty decent hodograph right there. Great low-level shear on that for sure. Deep moist layer. Low cloud levels, way too low. But yeah, it's a great sounding right there by the HRRR. I'm only gonna do one sounding because I'm kind of running low on time. So let's kind of just run through the simulated reflectivity. So right over here, here's the HRRR as I was showing earlier. And then down there, you got those supercells at about 8 p.m. All right, NAM model. This one's a joke. Do not trust that. There will not be 500 million supercells. Can't use the name for really East Coast states. Then the next one, the HRW. You can read it yourself. I'm not pronouncing all that. There's your rain band moving through, and you got that line right there. Yeah, this one's actually showing supercells earlier in the day with that little cluster that we were talking about. So this is 20Z, so this is 3 p.m. right down there. You got a long track tornado. Do not take this seriously. Listen to the warnings. But down there in South Carolina, you got yourself a long track tornado and another one. And then right over here, we got the NSSL version of this. If we move this through, there's your rain coming through. And then right there, you do got yourself a supercell down there in South Carolina at about 7 p.m. Could produce a brief tornado. And then that's the only storm that actually pops off with that line, looks like. Then let's look at the HRW V3. This one is one of my favorite models. I do trust this model quite a bit. And that one is showing that line, maybe with one supercell in it. Then we got another one of my favorite models, the RRFSA. Actually, hold up, we gotta go back to, never mind, that one doesn't have an 18Z. Alright, here's 18Z of that. There's your morning convection. And then a big mess and possibly a supercell with that mess. Yeah, that one's showing a big mess. Alright. And then right over here, it's basically all the models. Let's see this one. This one doesn't go all too far. This one's like for Canada, so yeah, I'm really just gonna use the surface base energy, which is decent. Alright. Hey Stars, I mean Carolina Chase, you can call me whatever. Alright, we are gonna end this live stream and I'm gonna hop in a VC with some people in the Discord server. If you're not in the Discord server, be sure to join it. But that's really all. I hope you guys did enjoy the video. I will be going storm chasing tomorrow, 99% chance of that. But yeah, that's really all. So I'll see you guys in the stream tomorrow. Bye.